In our previous lectures, we had met defining our own functions. In particular, we had defined the function square, and the code for defining the function went somewhat like this. And as you can see, I have defined a function here, or at least I have started defining a function here using the def keyword as always, and then the name of the function, square, then two arguments, L and C, both of which have been given default values, so that I can even call this function without mentioning any arguments, in which case the default values are going to be used. Then, as we have seen several times before, the pen color, the color used to draw the square, has been set to black or set to C, whatever value the variable C has. If I do not supply the second argument, it's going to be black by default. Then I have this loop which will run 4 times, and each time the loop runs, I takes the values 0, 1, 2 and 3. The body of the loop will be executed, so the cursor will move forward. That's what fd, the function, does. Fd by L units or L pixels on the screen, and then it's going to turn right through 90 degrees. So this is basically what this function is supposed to do. I've not completed the function yet. So far, all our functions have just drawn on the screen, but not talked back to us, not given us back any result. But in mathematics, we know a lot of cases where we have functions where we give an input and we get an output back. So one possibility could be something like this. I could use a print statement to say, give us the area of the square back. So we can even put a statement like this. Whatever you write within quotes, remember, is a string, and that's going to be treated literally as is. So when I say print and then I follow it up inside the argument with area is, which is a string, when the function reaches that line, it is going to print out area is followed by the square of L. Remember, in our very first lecture we saw double star is for exponentiation or power. So L double star 2 is L squared, which is L times L. And now let us finish the definition of the function this way. So I've defined the function square for you. And now that I have the function defined, let us call it and see what it does. As I said, I can call it without an argument given, because I have given default values to both its arguments. Now I am seeing that on the canvas, a black square, so C has a default value of black, and length 100 has been drawn. And more, well, not more importantly, but at least something that is new with this version of the function, in addition to drawing on the screen, what it has done is back here at the interpreter level, it has given me back this result. It's saying area is followed by a space. The space, of course, is this space here, and another space which is automatically inserted before the next entry comes in. So there are really 2 spaces here, and then the square of 100. I can, of course, draw other squares. Let's reset the canvas first and set the width of the pen to, say, 3. So I get a big fat line on the canvas, and then call it with something like square 200, red. I have given values to both the arguments. These are positional arguments, remember. L comes first, C comes next. So if I write these two in order, Python automatically understands that I want to draw a red square with side length 200. And that's exactly what it does. And it also talks back to me. It gives me area is 400,000 now. Oh, sorry, 40,000. Well, can I use this area to do any further calculations? So, for example, can I do something like this? Can I store the result of this calculation in a variable and then maybe find out its square root, for example, or, well, do other things with it. So let's see. Let's say I define a variable a and I try to store the result of the square function. So I've said square 200, which means, of course, is going to be a square of side 200 with color black, because as a default I've not supplied a second argument, and see what happens to a. Of course, the square is drawn, area is 40,000 is printed, but what is the value of a now? Let's see. I try to see the value of a. The interpreter gives me back nothing. In fact, let's see. One thing we can always do is check the type of whatever variable I have. I'm saying class none type. None is the operative word here. It means that the variable a has no value stored in it. Now why is that? After all, didn't Python calculate the area? Of course it did, but I did not ask it to give it back. The function that I had defined a while ago, there's two things. Okay, two basic group of things. First it draws a square and then it prints out the statement area is whatever L squared is. However, this function has not been asked to give back something to whoever calls it. This, in fact, is a big shortcoming in this function, because most functions that we will actually define and use really does this. Takes in arguments, does something with them, and gives back to the caller some result. Some object, which could be a number, could be an integer, could be a floating point, could be a string, whatever, but it gives it back. Here our function does not give back anything, not even the string it is printing. It just gives back nothing. That's why when you try to store the result that it gave back into the variable a, the variable a ended up being none type. Now that is not very nice. So can we do better? Can we ask the function to give back something to the caller? Of course we can, otherwise functions would not really be much use beyond just drawing on the screen. But for that we need to learn another keyword. And the keyword is pretty easy to remember. It is simply return. So give back, return means the same thing, but you have to use the word return here. So let's see. Suppose I want to write the function squared once again. It will draw the square as before. But what it will do is it will not print out its area, but it will return the area. So how does that work? Well, let's write up the previous parts of the function first. Color C, then for I in range 4, FDL, RT90. This part must be sort of memorized by you by now. Now comes the new part. Instead of printing out the area is this, what I want my function to now do is return the value. So that's where I use the keyword return, and returns whatever I wanted to return, in this case L square, so that the area of the square is returned. That's it. So the way to make your function talk back to you, give back something to you, is use the return keyword. By the way, every function returns something or the other. Even the function that we wrote earlier, which returned nothing. There was no return statement in that. That's fine. If there's no return statement, the function actually returns none, which is why what the variable a stored earlier was none. And it had nothing in it, as we saw. Now let us try running this function again. And let's go through this reset and wait 3 routine. And then let's call the function square with argument, let's say 250 now, and say blue. So it has done this, and at the end is showing a value 62,500 on the screen. Now what has happened here? The function did the drawing. That was what it was asked to do. If I had included some print commands inside the definition of the function this time, it would also happily printed out whatever I wanted it to print, but I did not, so no printing. Then returns the value L square. Who does it return it to? To whoever called it. In this case, the main interpreter program. Now, if I had actually tried to store this value in a variable, as I did the last time, then this returned value would have gone to the variable and you would have seen nothing on the screen. But now what has happened is that the return value has not been sent to anything. So Python sends it to the default output, which is just the screen. It sends out the output to the default. In this case, is showing up on your screen as the result. What I could have done is something like this. In which case, I'm not sure whether you saw this, so let me just try it again after the resetting. And then try this command once again. Sorry, I did not hit the enter after typing in the reset. So I did reset now. Let's set width to 3. And then let's run the function once again. So square was completed. Nothing came on the screen. Why? Because the returned value, L square, has actually gone into A. See, A now has the value 62,500. So here we have a function which returns a result. Now this is the kind of function that we will need very often, not really while we are drawing stuff on the screen, but in most practical applications, the functions that we are going to write will have an explicit return command or return part which will return different values to us. Just to show you how this works, let me illustrate with another function which has nothing to do with the turtle module or drawing pictures. It's something as simple as this. Let's say so this function is called cube. It doesn't try to draw a cube on the canvas. What it does is it takes in an input x, cubes it, that is multiplies it by itself 3 times, and then returns the value. So since it's such a simple function, I can even just write it like this. Of course, you could use exponentiation and write x double star 3 or write x star x star x. So this is your function. So if I called it with an argument 10, let's say, it will return back 1000. And because I've not given it to a variable to catch, it's getting directly displayed on the screen. So can I put this very simple function of ours to some use? Let's see whether we can use it to do something useful. Like, what if somebody asked me to find out 1 cube plus 2 cube plus 3 cube up to say 20 cube? How would I do that? I could of course use the cube function to calculate all these cubes and add them up by hand using a calculator or just in my head. But because we are using a programming language, we can do much better than that. So let me just point out that when you add several things together, what do you really do? Suppose somebody asked you to add 5, 6 and 7. You first take 5, then you add 6 to it, you get 11, then you add 7 to it. Although when we speak, we say add 5, 6 and 7, we can't really add 3 numbers together. We add 2 numbers at a time. And strictly speaking, what we do is start with a running sum in our head, let's say 0, and that value is 0 at the very beginning, when I have not given it anything. Then in comes 5, I add 5 to the 0, I get 5. So the running sum, the sum so far, changes to 5. Then I add 6, the next number. So the running sum becomes 11. Then I add 7 to the running sum, I get 18. So this running sum keeps on getting updated every time. So can I use this idea to add up, say, the first 20 cubes, 1 cube plus 2 cube up to 20 cubes? For that, first we need a running sum, some variable which will hold that. So let's call this r underscore sum. I have already talked about variables and what their names can be, although I have not stated all the rules precisely. But the basic rule is you can have characters and numbers in name of a variable. It has to start with a character, and special characters are discouraged, hardly ever used, except for the underscore, which is used pretty often. And here r underscore sum, the underscore simply is meant to divide the two parts of the name. What you cannot have in a variable name is a space, so you can't write r space sum. The computer simply will not understand that you are trying to define one single variable. So this r underscore sum is your variable name, and in that you store 0, which is of course what the running sum is when you don't have anything. So if I wanted to add the first 3 cubes, what I would do is something like this. R underscore sum, take the current value of r underscore sum, to that add cube of 1. Of course I could have done this in my head, but let me just show how the computer would get the commands one after the other. So r underscore sum now of course has changed from its value 0 to 1. Let me point out one thing here, which of course should be pretty obvious to all of you. We have been harping on about how the equal to sign here does not stand for equality but for assignment, and you can see that very starkly here. This would be absurd as an equation, right? R underscore sum cannot be equal to r underscore sum plus cube of 1. What is being said here is first calculate the right hand side by taking the current value of r underscore sum, which at that point was 0, and add to that the cube of 1. And whatever result you get, assign that, push that into the variable r underscore sum. So let's do it again. The next step of the sum will be this. So now 8, the cube of 2, has been added to the current value of r underscore sum, and so my value of r underscore sum is now 9. Well, I can keep on going like this. And so r underscore sum will be now 36. 1 plus 8 plus 27, and so on. Now doing this up to 20 is going to be pretty tedious, and if I wanted to sum up, say, larger number of cubes, this is really not the way to do it. But since we have talked about loops quite often in the past, it should be pretty easy to see what we should do here. What we should do here is rely on a loop. First, let's start all over again by starting with a running sum of 0. By the way, you do not have to call this variable r underscore sum. You can call it whatever you want, but keeping the variables reminiscent of what they mean is going to be pretty useful. So this is your initialization. Now you want a variable I to take the values 1, 2, 3 up to 20, and I know how to do that. I will use for I in range 1, 21. Just to remind you, range 1, 21 if you use that, it will return values which start at 1, then go to 2, 3, 4 and stops short of 21. Since I have not given a third argument to range, the increment is a default, which is 1. So 1, 2, 3 up to 20. And now this is my header line completed. And inside the body, I will write what I was doing so far. The cube of the variable I, which is the variable which is changing over the loop. So every time the loop runs, I takes a new value, 1, 2, 3 and so on. And every time r underscore sum, the running sum is being updated by addition of the cube of the number which is coming in. So if you are new to this kind of idea, I would urge you to sit down with pen and paper, pretend that you are the computer, write down the value of r underscore sum at each stage and see how the thing gets changed every time. That's perhaps one of the best ways to understand how loops work. Of course, you may already have understood this, but even if you have, it's actually never a bad idea to work it out explicitly, at least for the first few steps. So now the loop has been written, I run the loop and it's done. So all this rather tedious job of adding 1 cube, 2 cubes, 3 cube up to 20 cube times is done in a jiffy. And now let's see what r underscore sum is. Yes, 44,100. In case anybody remembers, the sum of 1 cube plus 2 cube up to n cube is actually n into n plus 1 by 2 square. So for 20 is 20 into 21 by 2, that's 210 square, and 210 square is 44,100. So our function cube, of course, works. It returns the right value, as we have already seen. And this summing up idea of starting with a running sum, keeping on adding terms, works fine. While this sounds like a very simple idea, summing up a lot of things is actually a very important thing to do in applications of computers. So this basic idea will be used over and over again.
There is plenty more to be said about functions and how to define them or how to use special features of them. And we will see some of these special features in the lectures to come. However, let me just talk about a couple of issues. Suppose I wanted to define the square function once again, but this time with perhaps length with a default value of 100, color, which is going to be inputted as a variable c, the default value of black, and maybe I will put the width as an argument w in the function definition itself. So now I have defined a function with 3 arguments. L and C here have default values. W, of course, does not. So let me complete the definition of the function. One would be width W, whatever the width is given. It is set the width to that. Color C. And the rest will be simply the square drawing loop. For I in range 4 colon FDL RT 90. And we are done with defining the function. But notice that the moment I try defining such a function, I am getting an error message. This is a syntax error. It says non-default argument follows default argument. Realize that if I at all had managed to define the function this way, Python would have been caught in a very ambiguous situation. If I had then called the function square with one argument, what would it understand? Is that going to be the value of L, the first argument? But that already has a default value. Or the value of W, the one argument which actually needs to have a value given. Python avoids such ambiguous situations by defining such an attempt as a syntax error. So Python has this rule that all arguments which do not have default values must come before arguments which have default values. Now you could actually try doing something like this. I do not want W to have a default value. So I'm going to force the user to give a value to W always. But I will now define its default value as none. Why? Because after all, it has to be an argument with some value by default if it is to come after L and C. And then we could do something like this. Now notice, I'm using this rather strange construct here. I'm saying if followed by what should be a condition. But actually what follows if is something which can give a true or false result. Now in Python, the understanding is none is false. So if W will work out as true if W has any value other than none, which means W's value has been given. If on the other hand W's value has not been given, this with W will not even be attempted, which means whatever default width the system had before that, that will be the one with which the turtle will draw. Then it's color C, and then comes the loop drawing the square. And we are done. Notice this time I got no error message. Things worked out fine. At least definition worked out fine. And if I call the function square without any argument, notice if I am calling it without any argument, L gets the default value 100, C gets the default value black, and W gets the default value none. Which means if W, that if block, fails, with W is not executed. So whatever was the value of the pen before stays. And so it has drawn a square with actually the value of width which is 3 because that was what width was set to before. And you can actually make out that this square has exactly the same width as the bigger square that was originally on the canvas. So the pen width has not changed. And just to remind you, if I wanted to just keep the default values for L and C, but give a value for W, the only way to do that would be actually give it its value by name. And now I've drawn a 100 length square with the color black and width 5. Now, one more thing might be worrying you, especially if I have programmed before. Can you return more than one thing? Can a function have more than one return statement? The answer is yes. But then, the first time a return is encountered, the function stops then and there, returns whatever value the return statement has asked you to return, and gives it back to whoever called it. So, if I define a function, let's say, called strange function x this way, and then return x cube, then there is nothing wrong in the syntax there, but it's rather useless because if I call the function strange f with an argument 10, the function will work, will return a value, but it will return 100 because the first time it encounters a return statement, here return x square, is done. It calculates x square, returns the value back to whoever called it. It does not even go to the next line. Of course, a situation where there are multiple return statements may not be that hard to imagine. You may have a condition. For example, if x is greater than 5, square, else now this is perfectly legitimate and also quite useful. Of course, here the function will return x square if the argument given is more than 5. If it's less than 5, it will return x cube. So if I call this function not strange f10, and of course the else clause does not kick in. X is greater than 5, so what you will get is 100, because that's the square of 10. On the other hand, if I give it the argument 4, then the else clause will kick in and you are going to get 64. So this is perfectly valid. You can have multiple return statements in a function, but those multiple return statements will be, only one of them will be active. Whichever one is encountered first, that's the one which returns. But suppose I wanted a function which returns both x square and x cube. That is, I want to return both of them at the same time. Now here we meet a small impasse. The rule in Python is a function can return only one object at a time. So it cannot return two floating point numbers or two integers. That's out. However, notice that the condition says one object, does not specify exactly what that object is. So let's define a new function multi-out. Is an argument x again, and let's say I put this in the return statement. And this definitely works, at least the definition worked, there were no syntax errors. So let's see what happens if I call it with multi_out 10. Well, I'm getting two numbers, but I'm really not getting two integers. I'm getting two integers put in a round bracket. Now this is the kind of object that we have not seen before. We have seen two numbers placed in a square bracket. That was a list. This one looks similar. There are two integers separated by a comma, but they are put in a round bracket. So let's ask ourselves, what is the output really like? What kind of object is it? So for that we need the type command. Unfortunately, we did not store the result of the last function call in a variable, but there is a default variable called underscore in Python, which always stores the last result. So this is a trick. If you have forgotten to store the last result, you can always get it back by using underscore. And here it's saying class tuple. So this is a new kind of object. We had met lists and strings before. Both of those were iterables, things with multiple pieces. This is a new kind of iterable. It is called a tuple, and it's really multiple things put together, very much like a list, but there are a few differences. In fact, there is one major difference. So to understand what that is, let's try calling multi-out again, and let's save the result of this function call in a variable t. So t is this tuple. Remember, tuples are written with round brackets. So So just like lists and strings, you can index elements in a tuple. You can call them with T0, that is going to be the 0th, what we usually call the first element. T1, which is 1000. T minus 1 counts from the back. T minus 2 is 100 as expected, second element from the back. T3, as with lists, is an index error. Here is saying tuple index out of range. With lists, this would have been list index out of range error, but very, very similar. Okay? So what is the difference? The difference simply is here. Suppose I tried this. Then I get an error. It says tuple object does not support item assignment, which means that unlike lists where I can change the elements in the list after we have created them, a tuple is immutable. You cannot change the elements of a tuple once you have created it. In that respect, tuples are very much like strings. So tuples are immutable like strings, but they actually behave in other respects almost exactly like lists. However, coming back to our function which returned multiple values, we realize now that Python has gotten around this restriction of not being able to return multiple objects by packing all of these objects into a single tuple and sending the single object, the tuple, back to whoever called it. Now, this actually is technically called packing. Whenever you put multiple things in commas without specifying that you want a tuple, Python understands that you are actually creating a tuple, so it packs all of them into a single tuple. So you don't really have to write the round bracket. It would not harm if you wrote it, but you don't have to. But say I want to call this function multi-out, but I want to save the result in two variables. Now Python gives you a rather nice way of doing that. I know that the tuple has two elements. I can put two variable names separated by commas on the left hand side. So the moment you do that, what has happened is multi-out 10 returns the tuple 100, 1000, two elements, and Python then unpacks the tuple into these two variables. So xsq is the 0th element, which is 100. xcu is the 1th element, which is 1000. So this packing and unpacking of tuples, that is, things separated by commas on the right hand side of an expression automatically become packed in a tuple, and on the left hand side of an expression, if you have multiple variables separated again by commas, and you have a tuple, or in fact any iterable on the other side, if the tuple is split into various elements, this is a very, very important feature in Python, and it comes in very handy. You will see more and more uses of this as time goes by. One use is a classic one, which is something like this. Suppose I had two variables, A is 10, B is 5, and we wanted to swap their values. Now, something simple-minded like A equal to B and B equal to A simply will not work, and this is something which anybody who has ever studied computer programming knows, because this is one of those classic problems in computation. Why doesn't this work? Because the moment you wrote the first assignment A equals B, the value of A is lost. The value of B, namely 5, is now stored in A as well. And then if you tried B equal to A, B will merely be getting back the value it pushed into A while ago. So B will be also 5. So B will not be 10. The point is, the value of A, which was 10, has been lost the moment you tried this. A traditional way of swapping the values of two variables is something like this. To prevent the loss of the value of A the moment you tried the assignment, you first save it into a temporary variable. I'm calling it T now. Of course, T was a name for the tuple a while ago, but it doesn't really matter. I'm saving the current value of A in a temporary variable T. And then I'm assigning the value of B to A. So, T, remember, now is 10 and A has become 5. And then B will not be getting its value from A, because then it will just get back 5. B will get its value from the temporary variable T that we have stored. And now I have managed the exchange. A is 5, B is 10. However, Python allows you to do this with much more finesse, with an obvious sounding statement. Of course, A and B have already been exchanged. So if I swap them again, A should go back to 10, B should go back to 5. And Python allows you to do something which seems trivial. You just say A comma B equals B comma A. Now what is happening here behind the scenes is this. On the right hand side you have this expression B comma A. You have no round brackets or anything, but Python still understands that what you want to do is pack these two values B and A together in a tuple. So the tuple that is created is 10, 5. So that's for the right hand side. That's created first. Now that tuple is going to be unpacked into A, B. That is, the first element of the tuple, 0th one, is going to go into A, and the 1th one is going to go to B. Since the tuple B, A is 10, 5, its 0th element is 10, that goes into A, and the 1th element, 5, goes into B. So see, check, A and B have come back to their original values. So second swap that we did right now, just by using tuple packing unpacking, immediately gives you back the swap.
In this lecture, we have not drawn many pictures. I'm sorry for that. The only pictures we drew were squares. A few squares at the beginning. But let me promise you, by utilizing these ideas that we have come up with, we will soon be drawing very, very interesting pictures in the coming lectures. So bye till then.